Today's lesson is on the solubility rules for ionic compounds. Now, this is very important to know. This applies to ionic compounds. That means compounds that usually are metal, non-metal, or just positive ion, negative ion. Okay, these do not apply to acids. Later on we'll talk about acids, so these are only for ionic compounds. So give you a couple seconds. You can pause the video so you have a chance to read through these rules, and then we will go through each one of them. So go ahead and pause it, and then after you read through it, restart the video. Okay, so the first rule says alkali and ammonium salts are soluble. So the word salt is another chemistry term that represents ionic compounds. So it's saying any ionic compound that has an alkali metal, those are any elements in the first column of the periodic table, that's from lithium. Of course, you always exclude hydrogen, but we have lithium, sodium, potassium, rubidium, cesium, and francium. Or if the ionic compound will contain ammonium, they will dissolve. Okay, a good example of that would be if I gave you this compound right here, potassium sulfide. Potassium sulfide formula would be K2S. Because it's got the potassium ion in it, this compound, even though I doubt anyone in my class has ever used it, if you were to put that compound in water, it would dissolve in water. And it turns out, put that into water, this compound would dissolve in water. Okay. And then compound with ammonium would also dissolve. Rule number 2 deals with anions. We have NO3, -1 nitrate, acetate, and chlorates dissolve in water, ionic compounds. Third rule, chloride, bromide, iodide. Usually the halogens. We usually call them the halogens. The chloride, bromide, iodide ions, the halides. Salts are soluble, but there are 3 exceptions. The 3 exceptions are when those halides, chloride, bromide, iodide, are with silver plus, that's mercury 1 ion and the lead 2 ion. Rule 4, sulfates are soluble, and this one, there's more exceptions. Silver, mercury, and lead. These are the 3 same exceptions for the rule 3, chlorides. And then we have calcium, strontium, barium. Calcium is element number 20, strontium number 38, and barium number 56. Calcium, strontium, and barium are both alkaline. All 3 are alkaline earth metals. And rule 5, sulfites, carbonates, phosphates, and oxalates are not soluble. So watch this, rule 5. These compounds are not soluble, but there is an exception. Unless they're with alkali metals or ammoniums, they will be soluble. And rule 6, I don't know why there's no parentheses here, but it's hydroxide salts. Hydroxide compounds are not soluble unless with alkali, ammonium, and calcium, strontium, barium. Calcium, strontium, barium, these are the 3 exceptions for the sulfate one. Calcium, strontium, barium are alkaline earth metals. Alright, so let me give you a couple examples. We'll do them together, and then I'll have you do a couple on your own. So how about this compound? If we go to this compound here. Okay. Sodium chloride. Okay. According to the rules, is it soluble or insoluble? Well, according to rule number 1, because sodium is an alkali metal, this would be soluble. So to represent it as being soluble, we put in parentheses subscript AQ, means it dissolves in water. The K2S, we said before, it also soluble, so we'll put on AQ. And I'll put the number 1 here so we know what rule tells us it's soluble. You are not responsible to memorize the rule numbers, just know the rules. Okay. I just put the numbers there so that when you look back at your notes, you can look back and go, oh, that's why it's soluble, because of rule number 1. If you also look for NaCl, rule 3 would also tell us that it's soluble because it's got chloride in there, and chloride compounds or salts are soluble. Okay. Next example would be iron 3 nitrate. Iron 3 nitrate. Okay. So according to the rules, would this be soluble or insoluble? Well, there's no mention here about iron, but there is mention about nitrate. Rule number 2 says all nitrate compounds are soluble, so we put on AQ. So it's soluble because of rule number 2. Sodium acetate. Let's try sodium acetate. So, according to the rules, rule 1 says it's soluble. Sodium is an alkali metal, and acetate is rule number 2. So rule 1 and 2 tell us it's soluble. A little side note here, none of these rules will ever contradict each other. One rule, you will never have a situation where one rule says soluble and then another rule says it's insoluble. They always work together. Next compound is silver chloride. Okay, so here we go. Chloride. Rule number 3 says chlorides are soluble, so this should be soluble, but hold on. Chlorides are soluble except with silver, mercury, and lead. This has silver, so this is the exception. So instead of being soluble, it's insoluble. So to represent insoluble, it does not dissolve, it stays as a solid. So we put down subscript S in parentheses, and we'll put down rule 3 to note that it is not soluble. Okay, and if something's not soluble in our reaction, what it would tend to be, it would usually be a precipitate. Okay, that we've seen in some of our double displacement reactions and single displacement reactions and some other experiments throughout the semester. Let's go next to barium sulfate. Barium sulfate, BaSO4. Alright, let's go sulfate. Sulfate rule number 4 says sulfates are soluble except silver, mercury, lead, calcium, strontium, barium. So barium sulfate is not soluble according to rule number 4. So it's not soluble, we put subscript S. The last one we'll do together is ammonium sulfate. Alright, give you a couple moments here. Ammonium sulfate. And according to rule 1, ammonium compounds right here are soluble. And rule 4, sulfates are soluble. So once again, none of these rules will ever contradict themselves. So we find out that it is soluble. So to represent soluble, dissolves in water, we put the term aqueous or aqueous. Okay, so here we go. Let me give you a couple of them. You can pause the video, take some time to look through the rules and identify if it's soluble with the subscript AQ, or if it's not going to be soluble, you put the subscript S in parentheses. Okay, so let's go with first nickel carbonate. Let's go a different color here. Change it up a little bit. So we got nickel 2 carbonate. For example, we'll have sodium carbonate. Copper 2 chlorate. And barium hydroxide. Let me give you 4 more here. Let's go with sodium hydroxide. Lead 2 chloride. Lead 2 chloride. Lead 2 nitrate. And ammonium nitrate. Ammonium nitrate. Okay, so go ahead and pause the video. Use the rules above and apply which ones are soluble and insoluble. You will have to memorize all 6 of these rules for this course. Restart the video when you are done labeling soluble or insoluble compounds. Alright, here we go. Nickel carbonate. Turns out it is insoluble. Not soluble, forms as solid. Sodium carbonate is soluble. I'm sorry, nickel carbonate is not soluble because of rule 5. Sodium carbonate is soluble because of rule 5 and rule number 1. Copper 2 chlorate is soluble because of rule number 2. Barium hydroxide is soluble. Hydroxide is normally insoluble, but the exception, so therefore it is soluble because of rule number 6. Sodium hydroxide is soluble, AQ, because of rule 1 and 6. Lead chloride is insoluble, solid, because of rule number 3. Lead 2 nitrate is soluble because of rule number 2, and ammonium nitrate is soluble because of rule number 1 and 2. So make sure you memorize these rules, and I will see you later in class.